Hey, this is Jeremy, and today we're going to be talking about gas exchange in the alveoli and kind of what goes into that process. So what you'll notice is we have the pulmonary artery over here on our left-hand side, and your pulmonary artery is actually going to be receiving its blood from your right ventricle. So your right ventricle sends to your pulmonary artery, which is going to be represented by this blue that's right here. And then right here in the purple magenta, this is going to be our capillary. So this is where gas exchange actually takes place over the alveoli, which is going to be represented by the green. Now we have our pulmonary vein, which is going to be the red, and it actually ends up going into your left atrium and your left ventricle, which pumps that blood throughout the rest of your body. And so to start off with, what we have, the big thing that we need to understand is the air that we breathe. So the air that actually is going to be coming in to our alveoli and being able to participate in that gas exchange is made up of a couple different things. So the most abundant source, or the most abundant gas that is in the air that we breathe, is nitrogen, and it's about 78% of all the air that we breathe. Now, this nitrogen is very important because it makes up the dead space of our lungs, and we're going to be talking about that in a different video. Now, next up is we have our oxygen is the next most abundant gas that we have, and it's 21% oxygen. Okay, and so this 21% oxygen is actually really important because this is what we're breathing in. Now, if you add 78 and 21, that gives you 99. So we actually have 1% of all other gases, or this rest of this 1% is going to be made up of other gases, and part of that 1% is going to be the CO2. And so that is an incredibly important concept to understand. We have a very low concentration of CO2, and we have a very high concentration of oxygen. And so the way that your alveoli works is through a process called diffusion, which essentially takes solutes, okay, which are solid particles. So we're going to say a gas, and it's going it from a high to a low concentration. Okay, so I have a high concentration of oxygen, and then that high concentration of oxygen is going to get diffused into the capillaries, and where there is a low concentration of oxygen. And the same thing is going to be said of the carbon dioxide, which has a high concentration inside the alveoli and a low concentration, or a high concentration, as it crosses over the alveoli from your pulmonary arteries, and then it's going to diffuse across. So what we're going to be looking at is we have our CO2. CO2 in this circumstance is going to be represented by the yellow. Okay, and then so over here we have our O2 is going to be represented by this purple color. So keep that in mind as we're working through this next process. So as air comes in, it has a very high concentration of oxygen, and it has a very low, 1% of all the air that is coming in is actually going to be made up of this oxygen. So, or of the CO2 is a very high concentration of the oxygen. And so now what we have in the pulmonary artery is we have a very low concentration of oxygen, but we have a very high concentration of CO2. Okay, and so that's what we're going to see right here. Now, in our capillaries, this is where the exchange actually happens. So I have a very high concentration of CO2 right here. Okay, and so what happens is this CO2 is going to go across your capillaries, and it's going to all be going out. And so your CO2 is going to be going out. Now, our oxygen has a very low concentration of particles over here on our artery side. And so what's going to happen is we have our high concentration of air, or a high concentration of oxygen in the air that we breathe, and then it's going to be coming in. And so what this is going to leave us with this is going to leave us with a very high concentration of oxygen as it enters our pulmonary veins, and it's just going to continue to circulate. Now we are still going to have some CO2 that is going to make it through and be circulating throughout our pulmonary vein. But the big thing here is it's all about balance. Okay, so what we have is we have a box. Okay, and in this box we divide it up into two places. So what's going to happen is if I have, let's say that I were to have 6 CO2 particles over here, and then I were to also have 6 O2 particles over here, but I were to have 2 oxygen particles over here, and I were to have 2 CO2 particles over here, what would happen is over here we have a very high concentration of CO2 and a very high concentration of oxygen. So what would happen was we would actually have the particles, they would move over here to this side to even out. Okay, and it's just like water. Water is always going to flow to the empty container. So if I have a bottle of water, I can just pour that bottle of water into an empty container and it's going to go in there. So what we have in the normal circumstances that we're talking about, we have a high abundance of oxygen over here on one side, and so this is going to be the air that we breathe, and this is going to be the inside. So this is going to be the blood that is circulating at the capillaries, and we have a very low concentration of CO2. So what we have over here on the inside is we have a very high concentration of CO2 because this just got done circulating throughout the body, and we have a very low concentration of oxygen, just what is residual and left over. So what happens here is an actual exchange. Okay, and so it is all about the exchange. Okay, and so we have the oxygen is going to come over here until they are equal. Okay, and then we have our CO2 is going to come over here, and it's going to cross this membrane until they are equal. Okay, and so this is a very, very, very important concept to understand, is they are all going to equal themselves out. And that is the big thing about diffusion, is it creates equal concentrations on both sides of the membrane. And the membrane that we're going to be talking about is the capillaries. And so it's all about balance. We can't have too much CO2, we can't have too little, and we can't have too much oxygen, and we can't have too little oxygen. And so this is the down and dirty version of what happens in the alveoli and how gas exchange works.